Ok, vamos a publicar. Ok, ya quedó. Vamos a Facebook. Facebook, yo ni siquiera abro Facebook ya. Vamos para chatear con la familia y los amigos. Se acabó. No hay nada ahí. Ah, no, me equivoqué. Okay. Well, this is going to be a stream in English. Why not? It serves me to practice my English. Okay, let's try it out. Oh, I'm not even logged in. Okay. Okay, so today we're going to continue studying Python. Off stream, I watch a couple of videos for the next assignment. Okay, wait. What? Again. Ah, ok. Bueno, ya jalo. Okay, it's done. Yeah, perfect. Now I remember why. Oh, pero tampoco voy a poder ver qué está pasando ahí. Okay, never mind. Okay, first things first. Let's update, just in case. No update. Okay. It's time to throw down. Show me what you got today. We change. So, yesterday we were working with this. What? No, not now. Thank you. All of my courses. There we go. So off stream, I watch 3 videos. Developer Fundamentals 2, which is basically how to comment your code. I watched this yesterday. Today, I got this one here, password checker. I was hoping to see a method for strings in Python that allow me, or maybe for input, that allow me to get data without typing out the characters in the input field. Pretty much like when you input your sudo password inside Linux Bash. And list. I'm going to rewatch this one. I wasn't putting too much attention for this one. Anyway, so let's try that. My AC is dead, but I'm going to hold the heat today. I live in a very hot area, by the way. Let's shut down the Spotify for a while. Okay.
Welcome back. Let's talk about our next data type, and it's a big one, a very, very useful one. It's called list. And list is an ordered sequence of objects that can be of any type. So you can think of them as strings, right? We had strings previously that we learned about, except that each sequence of the string, was a string, was a letter or number wrapped in quotation marks. Lists, on the other hand, looks something like this. Let's say we create a variable li, and lists we denote with square brackets. And inside of these square brackets, we can have different objects. So for example, we can have 1, 2, 3, 4, 5. We can also have, let's say, li2, and this is going to have a B, C, and it can have any collection of items that we want. We can even mix and match and say that we have 1, 2, then A, then maybe even the Boolean value true. So all of these are lists. Now, lists are extremely important. And in other programming languages, you might have heard the word arrays. So in Python, lists are a form of array. And later on, when we get into the modules section of the course, we will talk about the difference between lists and arrays. But if you are coming from a different programming background, then lists are like arrays in your language, a collection of items. Now, the neat thing about lists is that it's the first data structure that we're learning. Now, what is a data structure? Data structure is a very important concept in programming languages. It's a way for us to organize information and data into, let's say, a folder or a cupboard or a box, so that these data structures can be used with different pros and cons. For example, you have a fridge where you store your food, and fridges are really, really good at putting your food inside, keeping it cold, and then taking it out. Or you might have a backpack. A backpack is really, really good to stuff everything in there, but when you're looking for things in a backpack, it's really, really hard. So you can think of data structures similar to that. A container around your data that has different pros and cons of accessing that data, removing that data, writing data, but that's something we'll get into a little bit later. The key here is that these square brackets allow us to contain information and data, like strings, integers, floats if we want to, booleans, into a contained fashion. So let's think of a good example here. What if we had a shopping cart? Let's say we're Amazon here, and then Amazon has the Amazon shopping cart. And in here, we can collect different things that we want. Maybe we collect some, I don't know, notebooks. And you know what? Let's get some gadgets. Let's get some, maybe some sunglasses. We can add different items here, different strings, different data into this cart. And now, just like we saw in strings, we can access the Amazon cart in different ways. For example, I can access it, again, with square brackets, and simply say I want item 0. So if I print here, do Amazon cart.
Notebooks.
Look at that, I get notebooks. The second item?
Similar to an array.
Sunglasses.
Not the same, if I recall.
Nope, list index out of range. But this should make sense now. This is a list where we're accessing the index of, but it only contains 2 items. So if we're going 0, 1, 2, the third item, nothing exists. So our program says, that doesn't work, you're doing something wrong. And just like strings, these list items are in memory, in their separate bookshelf, right? But one right next to each other. So we can go 0, 1, 2, 3, 4, 5, so on and so forth until the list ends. All right, let's learn about lists a lot more in the next video. Bye-bye.
Okay, so that's the introduction. That's why I don't really remember that video.
Let's continue with lists. Now, so far, these square brackets, we've seen them before, right? We saw them when working with strings. And just like strings, lists are quite similar in that we can use list slicing. If you remember, with string slicing, we had things like hello, and we were able to assign it to a string, let's say a variable string, and we can do string and then slice. So do something like this, where we have the start, the stop,
0 to stop, and the
so that we start at index of 0 and end at index of 2.
0,
and then go
1,
1 by
2.
1. So list slicing is also available to us. So let's make this cart a little bit bigger. And you can actually
list slicing.
By formatting.
That's interesting.
All right, so what should we add to our cart? We'll also add some toys. And then, you know what? Amazon does groceries now, so let's add some delicious grapes. Awesome. Now, let's say I wanted to get every single item in the cart. Well, we just simply do this, and we have our entire list. But let's use some list slicing. Let's say I wanted to grab from the first item to the second item. If I click run, I get notebooks and sunglasses. Maybe I want to go all the way till the end, but skip every second one.
Okay.
I get notebooks and toys. We start at 0, we step over to toys, and we step over, and we're done. Awesome. And this is something that we've already seen when talking with strings. Okay, but here is where it gets interesting. Remember how I said that strings are immutable? That means we can't change them, right? And we talked about this. When we had a string like hello, I couldn't do greet 0 equals to, let's say, z. I'd get an error here. I get str object does not support item assignment. It's immutable. But the interesting thing with lists is that they are mutable. So that if I change my Amazon cart and say that, you know what, I don't really want notebooks. So I'm going to grab the first item, which is notebooks. And instead of notebooks, what do we want? We'll say we want a new laptop. It's a big upgrade. When I print this Amazon cart, look at that.
Whoa.
Change this list. And
So the list is not immutable.
We simply replace
It's
on the memory
mutable.
bookshelf of our
Okay.
notebooks, and I say, hey, change it to laptop. And they let us.
Nice.
Okay, so that's awesome. But let's try something.
Tuples are not
What if I create another print?
immutable, are
And
immutable.
in the Amazon cart, I'll use list slicing. So let's say I want item from index of 1 all the way until index of 3. Let's run this and see what happens. Try and guess.
Yeah, it's going to.
Is that what you expected? Let's go through this.
No.
When we get to line 10, we grab the Amazon cart, which has been updated with laptop.
Okay.
And I grab item 1, 2, 3. So that is sunglasses to toys.
Toys.
0, 1, 2, and then we stop at 3. To
Yeah.
make this easier to understand, let's start off with 0 here.
It printed
see the laptop
everything
has been
though.
changed.
Ah, no.
Here,
Yeah.
in the second one, on line 11, we print the Amazon cart. But hold on a second.
Yeah.
This list did not change. And that is because with list slicing, we're creating a new list, a new copy of this list. So here, we're creating an entirely new list. So that I could actually assign it to
okay.
a new cart is going to be Amazon cart.
So the
Amazon
slicing
sushi.
is immutable.
And new cart
Okay.
is an entirely new list on its own. I could change new cart, let's say 0 into.
Just
let's say,
copying the data into a
if I
new
print it,
list.
You see that I have 2 new separate lists. But a list is mutable because I can change whatever is at
Yeah,
the
it's
index
mutable.
anytime I want. And every time we do list slicing, we create a new.
Slicing
that list.
is not mutating
What happens if I just do this?
the list.
If I run this?
The same.
See that?
Yeah.
Instead of slicing my list, I simply said that new cart is going to equal the Amazon cart. And I changed the new cart, index of 0, to equal to gum. But now my Amazon cart got modified as well.
Yeah.
Why is that?
Because
And this is a bit of a tricky question.
Just
You might encounter
because-
in an interview. The reason is that right
Well, I already saw that one on Java because Python does have some similarities with Java. Basically here, when you are doing the on line number 10, when you are equals new cart equals Amazon cart, what you are doing there, you are not copying a new, you are not creating a new list. What you are actually doing is saving the reference to the list into a new variable, which means that the part of the list that holds the name of the variable and the memory address of the actual list, those are stored in a variable, but the object itself is another entity that lives in another direction inside the memory, which means that these two variables are pointing out to the same object, basically. So it's like using two different labels on the same can, to call an example here. So basically, you put a label that reads Coca-Cola can and another one that reads Pepsi-Cola can, and you stick them directly into the same can. Whenever you ask for, okay, pass me the Coca-Cola or the Pepsi can, basically both instructions are going to give you the very same can. This is just labels, but the underlying object is the list itself. So that's why it seems like it's being copied at the beginning. However, when you change the underlying object using whatever of the two variables you want, the underlying object is going to change for both variables, basically.
now, the way that I did equals means that, hey, new cart is going to equal Amazon cart. And what does Amazon cart equal to? Well, Amazon cart points somewhere in memory in our machines that says, hey, this is what Amazon cart is. So because here we're not copying the list, instead we're just saying, hey, the value of new cart is whatever's in the memory of Amazon cart. We now, when we modify new cart, are simply changing the Amazon cart all the way back from here. So this is an important concept. If you want to, let's say, copy a list, then you do something like this, where you copy the entire list, and this is something that you'll see a lot in code bases. But this line is saying, hey, I want to create a copy, use list slicing to copy this Amazon cart, and it's going to equal new cart. So that now, if I run this, you'll see that the original Amazon cart stays the same, but the new cart is now something different. This is a quick gotcha that you just have to get used to, but it's an important concept, this idea of copying versus modifying the list. And it's something we'll explore a little bit more in the next couple of videos. For now, take a break, and I'll see you in the next one. Bye-bye.
Okay, that was nice.
Welcome back. I want to talk to you quickly about something called matrix. And a matrix is a way to describe 2D lists or multi-dimensional lists. What do I mean? Well, I can create a matrix. And this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And it looks something like this. It's an array with another array inside of it.
Oh, okay.
So let's say, for example, I have 1, 2, 3 here, and then another array, 1, or let's do 2, 4.
Those are nested arrays, basically.
And then another array, 7, 8, 9. What's happening here? Well, it's a 2-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is 2-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. The only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 0, or sorry, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner, then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I want to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix, access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do...
Oh, square brackets, okay.
1 here, and let's print that
1, so you're going to get 5.
And I click run. I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item.
Well, this happens because, well, I'm going to try to explain it a little better than my friend here. Okay, where is it? Oh my god. Are you serious? I need to change my tablet screen for the that's fast. It's not a big deal. I believe it's here. There we go. Let's configure. Okay, so which screen? Okay, tablet configuration. No? Oh, come on. Uh-huh. Okay. I don't see the configuration for no, I think it's in the Wacom app. Okay. I'm sorry. I'm making some configurations here. There we go. My devices. Okay. How do I configure this? There we go. There we go. Somewhere around here. Should be able to choose the screen. I don't see the screen. There we go. Projection. Okay, thank you very much. Okay. There we go. Second monitor. Is this working? There we go. Okay. So what he did is he started the array right here, the list, may I say, and it finishes down here. And between that, he is using these commas over here, one here and one here, to basically create a list full of lists. And those lists themselves may or may not have several other elements inside. So what he did here is that the first element, let's clear something of that. So what he did is, you know what, the first number, 0, is referring to the outer list over here. So 0 is going to be line number 1, or may I say, oh wait, what did I do? Oh no.
Welcome back. I want to talk to you quickly about something called matrix. And a matrix is
What
a
the
way
hell
to
is this?
describe 2D lists or multi-dimensional lists. What do I mean? Well, I can create a matrix. And this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And then another array, set. And then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is 2-dimensional, but we can have multiple ones. For example, we can have another array inside of this array.
Yes, okay. It went way too far.
Now, why is this useful? And by the way, this is 2-dimensional, 6, and then another array, 7, 8, 9.
Okay, let's leave it there. So the thing is, I'm going to have over here 0, over here 1. What happened? What happened? Uh-oh. Did I lose Epic Pen? Oh, it's here. Okay. Yeah, I don't know what happened. We're getting difficulties here. Never mind. Okay. There we go. There we go. Okay, I got it back. Never mind. So the idea here is I'm going to try to do it like this. You're going to be 0. Probably it's too big. Okay, let's try again with text. It's making this very difficult. I don't know why I'm getting this. But anyway, let's try it like this directly. This is the line item number 0, item number 1, item number 2. Okay. So every single one of those belong to an index for the outer. For in this case, it's called. Oh, okay, no. In this case, it's called matrix. So when matrix uses the first value, it's going to be 0. If I use, once I chosen 0, the second number is going to define which of those is next. For example, 0, then 1, then 2. Wait, can I move that one? Okay, great. No, never mind. So let's type it again. So you're going to be 0. You're going to be 1. You're going to be 2. So if I want whatever any of those values here, what I'm going to do is choose the outer value first. In my case, if I want to choose number 2, for example, this 2 over here. If I want this value here, the first index is going to be 0 because it belongs to the first element on the matrix. So I'm going to get 0. 0 over here. And the next one is, okay, in which column does it belong? Inside this list, on the index, the first index is going to be this one here. This is going to be 0. And the second is going to be 1, okay? I don't know why did I do that, but anyway. So this is going to be 1. So the second number is going to be 1. So the only thing I need to do is make sure that I assign those 2 values there. And as he mentions, I can include many more levels of nesting lists inside lists. And when I used to work for banks, I managed to include even the next one, which was called dictionaries. We haven't seen that yet. And another thing, very differently from arrays in Java, is that you can actually use or insert any kind of data type here, including classes. So objects are welcome here. You can insert lists inside lists. You can, you may use dictionaries. You may use even customized classes and objects inside here. So that's a really great thing to have, really. Let's continue.
What's happening here? Well, it's a 2-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now,
it's very hard in here.
And by the way, this is 2-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. the only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 0, or sorry, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner, then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I wanted to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix, access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do 0, 1. So if I go 1 here, and let's print that out, and I click run, I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item, which is right here, and then grab the second item in that array. So 0, 1, which is 5. And you can keep doing this. If you had multi-dimensional arrays, you can keep adding, keep adding, keep adding to access that information from an array or list. But remember, in Python, we want to use the term list. I'll see you in the next.
One important note here is that I don't really recommend going deeper than 2 levels of nesting list. This is because more likely than not, unless you're doing machine learning, I guess, because I haven't done anything of that, I don't really see the case or the sense of doing something like nesting 5, 10 levels maybe of nesting here, unless you're doing some complicated algorithm to do something really weird and nothing comes to mind. So you can use this as a list of lists. That's very useful sometimes. Maybe your list of lists needs another list sometimes. Maybe not. I don't know.
Bye-bye.
List methods. Okay, just like string methods,
right,
we do have
some actions that we can take on lists. This is very exciting because you can perform a lot of actions on lists. Now, we've learned about built-in functions, right? Functions that come with Python. And we've actually seen this one before when we talked about strings, which is the length function. And here, we can have it calculate the length of a list. So for example, if we had a basket here that had 1, 2, 3, 4, 5. Well, this basket, if I calculate the length of the basket, let's do print here so we can see the result. And I click run, I get 5. The length of the basket is 5 because, well, there's 5 items. Remember, a length is the actual length. It doesn't start counting from 0. It's going to do human length, which is 5. But lists get really powerful when it comes to methods. So instead of a built-in function, remember a method is an action that's owned by something, and it's specific, let's say, to a data type. So if we go to list methods, you'll see that Python has a few list methods that we can use. And the way we use these methods is, remember, we just add a dot after a list. So let's have a look at some of them. First, I'm going to start off with the adding ones. So let's say in this basket, we want to add something to it, to the end of the list. Well, we can use the append, and remember with a method, as soon as you write the dot, it'll tell you what we can use, which is very, very useful when you have an editor. So the first one is append. And if I hover over this, well, it just tells me appends an object to n. And in Python, an object is, well, everything in Python is an object. A number is an object, a list is an object. So just think of it as an item for now. So if I want to append, let's say 100 to the end of the list, then you know what? Let's add a new list here. And this new list will do the append for us. If I print the new list and I click run, I get none. That's weird. What if I print basket here? If I click run, all right. So it looks like the basket was appended to. We added 100, but a new list, when we assigned it the basket.append, that new list is completely none. And that is because append changes the list in place. What does in place mean? It means that it doesn't produce a value. All it does is say, hey, I'm just going to append 100 to this basket that you gave.
It doesn't return anything. Okay.
I'm just changing this for you. I know it's a little confusing.
It's an expression that doesn't return anything. Okay.
We have to do something like this. If I click run, there we go.
2 steps.
After we've appended to the basket, then we can assign that new list
got
basket,
it.
which points to
That's important, really.
All right. What else is there? Well, there's also something called insert. And you see over here that insert gives an index and an object. So we can insert something, not at the end of the list. I mean, we could, but we can also insert it anywhere we want in an index.
Oh,
for example,
nice.
in this case, if I do insert 100 at 0, 1, 2, 3, 4, so let's do index of 4, and I click run, I've added 100 to the index of 4.
Oh.
If I do index of 5,
And pushes everything to the right.
added 100 at the end of the list. Now, let's try and copy this and see if we can just add it into here. If I click run, again, same thing. Insert modifies the list in place. It doesn't create a new copy of the list. Right? And if we add this, like this, well, once again, insert modifies the list in
The
place.
list
That is,
itself.
doesn't really output a new list. It just modifies whatever
Doesn't
is
do
existing in memory.
anything.
Finally, there is another method called extend. And extend, instead of an actual item or object, takes what we call an iterable, which we're going to get into later on. But it's something that you can loop over. You can iterate
Like
over,
Java,
which is a
maybe.
list. So we just give it another list, like let's say 100 or 101. So if I run this, once again, it doesn't output a new list. It just modifies the list in place and adds on or extends.
Oh,
our list.
okay.
And we
Extend.
also just give it one item. All right, let's keep going with the removing.
Okay. Extend is
removing,
basically
Once again, have a few.
the classic, it's like the classic push method on some other object similar to a list here. Yeah, I get it. Okay, so in this case, it's similar like a queue, actually, because extend is inserting data at the end of the list itself.
So let's continue with this basket that we've been using that now has 100 included into it. And the way we can remove things is, well, there's a few ways. First one is basket.pop. And basket.pop,
The
if I
pop
go like
is going
this
to get the
and
value.
print this basket, I'm going to comment out the new list for now, since we're not using it. And then we're going to say basket.pop and then print basket. Let's run this. And
Okay.
pop pops off whatever is at the end of the list. In our case, at the end of the list, because we've extended the basket to 100, that 100 gets removed. If I do
So it's
basket.pop
basically a
again-
stack.
not here.
It's
down here.
not,
You see that both
okay.
100 and 5 get removed.
it's inserting things at the end,
If I click
it's
right here,
removing thing at the end. So it's
It
basically a
removes
stack.
the item in the index. So here,
Okay.
pop 0 is going to remove whatever's at index of 0, which is 1. Now, there's
So what I mean by that is when you have a data structure called, we call something a pile. Let's imagine that we have a container like this, and this is my pile of things, let's say. And when you insert a value here, you may insert the value 100. Okay, that's this is going to get inside with the extend. With the extend method, you are inserting a value here. You may repeat this with several other values like this. But the thing is that with the other, when you actually use the pop, when you pop a value here, it's going to pick up the uppermost value on the pile, and that's the value that's going to get popped. The first time it's going to remove 2. If I repeat this again, it's going to get me 13. Okay. If I repeat this again, it's going to get me 5. And we can repeat this as long as there are elements here. Okay. So that's the main idea. Extend is basically the push method in Java. The pop is pretty much the same method in Java also. Is to get a value from the, I guess that these methods actually mutate or change the list themselves. So, and they don't return anything. So basically I'm not creating a new list with a new set of values. I just basically modifying the list itself. And that's what is happening here.
also .remove.
Oh,
Remove, again, is we give it a value that we want to remove. So in our case, let's say we want to remove number 4. Well, if we run this,
it's
going to
the
remove
index
4.
4. Okay.
So remove, we give it the value that we want to remove. With pop, we give it the index that we want to remove. And just to see if this is working, let's add a new
Yeah,
list here.
sure.
And we'll say new list equals basket.remove. Add a new list here. See if
Yeah.
it's modified.
You get modify,
That means
none,
is working in place. It doesn't
working in
return anything.
place.
It just simply changes whatever list you give it. What if we do pop? If I run this, I get 5. Why is that? And this is something that you just have to get used to. Different methods do different things. For example, pop, the way it works is that pop returns whatever you have just removed. In our case, when we did 4, that is index of 0, 1, 2, 3, 4, it returned the number 5 for me.
Okay.
Even though it removed it from the basket, it still returned something. And the reason for others is that we got none. That is when a method doesn't return anything. It returns none. A topic we're going to cover shortly. So you have to be careful and understand what each method returns. If I go over extend, I see here that this little arrow shows me that none is returned. That means it's not going to produce anything with this method. It's only going to change or extend a list that it was given. Don't worry if this is confusing. That's something that you're going to get used to as we get more and more practice. Now, the last removing method I want to show you is clear. And clear, as you might guess, if I click run here, well, this is none. But if I go to basket and I click run, the basket is empty. Clear removes whatever's in the list.
Everything.
Just as the name suggests.
Okay.
All right, that was a lot, but there's still a few more. So let's take a break. And I'll see you guys.
Remove and clear. Methods, more methods for lists. Okay.
Well, let's keep going with some more string methods. Now we've learned about adding and removing ones. We learned about append, insert, and extend. And then in removing, we learned about pop, remove, and clear. There's a few other important ones. Let's go with the index. So instead of clearing here, let's clean this up. And we'll do basket.index. And index, as you can see, we give it a value, a start, and a stop. What does that mean? Well, we want to say, hey, what index is number 2? If we do index of 2 and I click run, it's going to give me 1. I know this is a little confusing, but it's asking for the index. Where is number 2?
Where is number 2?
Of 1.
It's pretty much a find command or a find method on Java, for example.
E. And again, if I do,
what happens?
I get an index of 3 because
3
0, 1,
is the first
3
time.
in our memory.
If I had repeating values, what happens
which is
the first
where should
time?
we start looking? So I want you to start looking at index of 0 and then
First
finish looking
index
at
value,
index of
okay.
2. If I do run here, I get an error. It says, hey, D is not in list because we started at index of 0 and stopped at index of 2. If I do 3 and I click run, nope, it stops right before.
Oh,
so if I do
where does it start and where does it end?
there you go, I get 3.
Okay.
Now, errors are not good in our programs. Ideally, we don't want to get errors. So how can we avoid this? What if we're looking for something and we're not sure if it's in the list or not? There's another nifty way of looking for things in a list. And this involves what we call a Python keyword. A keyword is something that you use in Python that, well, already has some meaning. For example, a keyword here, if I go to Python keywords, are all these words that already mean something. Now, we're and we haven't seen a lot of them yet. But we might have seen true, right? In Boolean values, true means something. So Python, we can't really
Boolean
use the
value
word
true
because, well, it already means something. There's a word called in that, as you can see, type means something as a keyword in Python.
It's inside.
It's quite nice. Okay. We can say, hey, is D in
basket?
And if I run this,
wow,
I get true. Okay, is X in basket?
No, false.
Because, well, it doesn't exist. And this is actually
wonderful.
And we can even do
it's really useful.
Let's say the letter I in a word, and let's say it's I in hi, my name is Ian. If I click run, I get true because the letter I does exist in this string. All right, let's learn another one. Another one is basket.count. And we can count how many times an item occurs. So for example, if I do D and I click
the number of elements,
1 because D only exists once in the list. But if I add another D in here and I click run, we get 2. It counts how many times this value occurs in our list. Very, very useful. All right, a few more still to go. Let's do some exercises and I'll see you in the next one. All right, it feels like it's never going to end. We have so many methods with lists, but like I said, lists have a lot of methods.
Wow, is list methods 3?
Trust me, these are going to become second nature. So hang in there. I have a few more to show you.
Okay.
Next one.
Okay, it's the last one for list.
Guess what sort is going to do? If I click run.
Dictionaries. Oh, come on.
But remember, sort sorts the list, as you can imagine. That means it modifies the list. So if I remove this up to here and then do sort or do basket, and I click run, look at that. I get a sorted list where D.
I wonder if I can define my sorting algorithm.
X at the beginning here. And I click run. It's going to move the X all the way to the end. It's going to sort the list in place for me. Again, if I hover over, it sees that it's going to not return anything, which is why our print initially didn't work. We had to print our basket, not whatever this produces, which doesn't produce anything. But what about this one? If we go to built-in functions, I have something called sorted. And if I do sorted, and because it's a function, not a method, I can do sorted dot or basket. So around the brackets, just like print. If I run this, all right, nothing has changed. But what if I remove this and put it in here? If I click run, I get A, B, C, D, D, E, X. What if I comment this out? So that we're not sorting it anymore. We just have the basket and then we run this sorted function. If I run, did you see that? Sorted, I know it's confusing. Why do they even have 2? But sorted produces a new array.
Oh.
So if I do print.
And sort doesn't produce anything. It just does it
hasn't been
in place.
The basket still remains the same. It's this one over here that's not sorted.
Yeah.
Sorted, on the other hand, doesn't modify the basket in place. Instead, it creates a new copy of the basket and sorts it. It's almost as if we're doing
interesting.
This. We're saying new basket equals basket, and then we're going to copy that basket, remember?
Yeah.
Slicing. And then we're performing new basket dot sort on this new list. So
okay.
New basket.
New basket.
We get
there we go.
So you have to be careful of certain actions that perform an action in place or create a completely new list.
I got to forget about this one.
Instead of this, a dot copy method that we can use.
Oh.
And if I run this, again, we
you
get
generate a copy.
As the name suggests, copy the list for us and return.
Way easier.
All right, one last one, and that is basket dot reverse. What do you think this does based on that?
It's going to invert the order of the elements.
And click run.
There we go. Yeah.
It reverses the basket.
Reverses the basket, yeah.
But notice that it's not like sort. It's not sorting. It's simply switching all the indexes.
Switching.
Sides. So D is now index of 0, E is now index of 1, index of 2, 3, so on and so forth. So you can see here that it doesn't actually sort it. Instead, what we might want to do is sort first, then reverse, and if we click run, we have a sorted reversed basket. This is a little tricky one that some viewers might ask. All right, good job getting this far. We're almost done with lists. So I'll see you in the next video. Bye-bye.
Okay. Almost. Come on, list patterns. Oh my god.
Welcome back. Let's talk about some useful tricks.
To be fair, it's really
See a
useful.
lot in Python code. Well, one we have already seen. It's this idea of length. You're going to be using this a lot. That is to figure out the length of a list.
If a list
In our case, is now
or
7.
a string.
Another really useful trick is to reverse a list. Now, I've already showed you how to reverse a list, but sometimes you can do that with list slicing. Again, something that we've seen in string slicing. So I can actually do basket and then semicolon, semicolon, negative 1. If I click run here,
Yes,
that
that's
what you
the step in verse.
just line by line. I've sorted the basket. So that's, it's
Okay,
A,
sorted.
and then I've reversed this, so it's
Reverse
Z all the way to A.
And then reverse it again.
again. So that
Yeah.
instead of being in reverse, it's now in order, A, B, C, D.
Yeah, it's in order again.
And
Okay.
this list slicing creates a new list, right? If I print basket here,
So that spits
you'll see
a
that
new.
the basket
Yeah.
is the reversed version,
the
the last
reversed
action that we've
version.
taken on it, versus list slicing that creates a new version. So this notation you
Okay.
see a lot with lists when you need to reverse it, or maybe you need to make a copy of the list like this, or maybe you need a portion of the list. Another useful thing that you'll see a lot of is something called range. Let's comment this out for now. If I wanted to generate a list really quickly, let's say from 1 to 100, I can do something.
Okay.
I can say range and then start and then stop. So let's do 100.
100.
If I print this and I run, I get a range 1 to 100. But if I wrap this in a list, which is going to create a new list for us, and I click run,
Oh, a
look,
function.
I get a
Whoa.
range from 1 all the way to 99. Remember, it's a
Okay.
start and then whatever to stop at. So before it hits 100, it's going to stop.
Maybe steps.
If I remove this and just do one single thing, I get
From
a list.
0
So from
to
0 all the way
100
99.
elements.
If I want a list
Okay.
that has 101 items because it starts at 0, I would just do 101. And range is something
Okay.
we'll talk about a lot more, especially when we talk about loops in programming. But this is a great way of you to generate a list really, really quickly, especially a numbered list. Finally, the last common thing that you'll see a lot is this idea of dot join. What is dot join? Join is actually something that works on strings. It's a string method, but it's often used this way. We have an empty string, and this empty string, let's say sentence. And then we can do sentence dot join, and join takes what we call an iterable, which is a list for now. And in here, we can have a sentence like, hi, my name is Jojo. And now if I print sentence and I click run here, I don't get anything. Let's figure out why. What if I type in an exclamation mark here and I click run? Right? It's printing out sentence, but it looks like dot join creates a new item for us. So let's just assign that to new sentence.
Join is like concatenate.
Now, if I do new sentence and print that out, we see that I get, hi, my name is Jojo.
Oh, okay. It's
So this is a
concatenating.
little funky, right? We have
Yeah.
these exclamation marks
Why?
between our items. And join joins these little iterable items, these lists, by whatever is in front of it. So if we actually
Okay.
change this to an empty string,
Oh, sentence.
click run, we now get this. If I add a space in between and click run, we get, hi, my name is Jojo. And sometimes you'll use this pattern a
okay.
lot, especially if you want to join and create a new string out of a list of items. Now, a shorthand way of doing this is to actually not even bother with this and just doing an empty string,
Oh, empty string.
joining
Dot
all
join.
list items.
Oh, okay.
So all we're doing is combining lists into a string, and this is a common pattern that you'll see a lot of.
Yeah, this is a really useful. This is a really useful video. Let's unpacking. I guess that's the
I want to
equals
teach you one last thing when it
to
comes to lists. And it's called
destroy arrays
And it's
in,
a really, really
in,
nice feature.
in JavaScript, for
list
example.
unpacking. We can do something like this. Let's say I have a list.
Deconstructing arrays.
Well, very simple, 1, 2, and 3. And I want to assign a variable to this list. Let's call it basket equals 1, 2, 3. But what if I wanted to assign a variable to each item? Well, I can actually do something like this, A, B, C. So that when I print A, and then let's print B,
It's already done?
C, and I click run, I get 1.
Wow.
And this is something that we've seen when we talked about variables, where even if it wasn't a list,
Yeah.
as long as we gave
Oh.
it by comma, separated by comma, different values, we're able to print.
It's going to be
This is where list unpacking
quite
gets
confusing.
really, really useful. We can actually, let's
For
say,
unpacking lists is great.
to include
For declaring variables,
what if we
not
wanted
so
to
much.
unpack 1, 2, and 3, but keep everything else still in a list. Could we still do that?
Okay.
Well, with list unpacking, we can. All we need to do is say comma and then add a star and give it a variable name,
okay.
whatever we like. Let's say other. So now if I print other and I click run, look at that. I'm
Wow.
able to unpack my list. However,
Everything inside other.
add a comment
Okay.
here.
Wow.
Add D.
D.
Well, if I run this, I get a list all the way until 8. But now D is, well, actually, the very last item. So that's very, very neat. Maybe the use case right now is not absolutely clear to you, but
Yeah.
this is something that might help you, another tool in your toolbox, to unpack a list and change a list in different ways. We'll explore this.
Yeah,
more later on in this course.
deconstructing lists
List unpacking. When you
is
figure it out,
really
now
useful in
go ahead. I'll see
JavaScript.
you in the next one.
I can figure out something. Okay, none.
Welcome back. When we talked about lists, we saw our special type of none, where some methods that worked on lists didn't really produce anything. They modified the list in place, but the output of whatever they were doing was
it's
missing
none.
Remember how we had in the output?
They don't
this none?
return
What does that
anything.
mean? If you remember, I mentioned none as a special data type that exists in Python. And most languages have something like this to represent the absence of value. In some other languages, you might have heard of null. Another thing that represents the absence of value. Now, why is this useful? Well, for now, it's hard to really conceptualize it. We'll see it being used a lot more as we get further into the course.
It's
but
no
it could be
data.
something like A equals none. Let's say, for example, we're just starting a video game. And in this video game, we have a user's weapons. But when you're just starting the game, there are no weapons that the user has. Well, in that case, we might want to assign the variable weapons. Maybe in our code we use this variable, but we also want to know that this user doesn't really have any weapons. It's none. So this is completely valid Python. If I run this, I get none. And we'll explore this a little bit more throughout the course, like I said. But hopefully this way, you're not intimidated when you see it. As the name suggests, it's just nothing.
Dictionaries.
Let's talk about our next data structure. And this one is called a dictionary. In other languages, it might be called a hash table, maybe map or objects. In Python, we have this idea of dictionary, or as Python likes to call it, dict. Have to make sure I pronounce that properly. That's a really hard word to say when you're recording and you're repeating it over and over. Anyway, dictionary. What is it? Well, it's a data type in Python, but it's also a data structure. Remember that I mentioned this idea of data structure when we talked about lists. They were the first data structure in Python that we learned. It's a way for us to organize our data in a form that has some different pros and cons on how we access it. For example, with lists, we saw that they're easily ordered. We can access them through indexes, like 0, 1. We can reverse them. We can insert into them. It was really, really nice. What about dictionaries? Well, let's see what a dictionary looks like.
Dictionaries are more
Something
complex.
Like this. We'll have a key.
Yeah, a key and a value.
Then another comma, and then another key, and
Another value.
Let's decipher this. So I'm using curly brackets here, which denotes a dictionary. And unlike a list, we have what we call a key-value pair. A key is a string for us to grab the value. What do I mean? Well, in order for us to access any of these values, I would go dictionary, and then say the key. In our case, let's say we want to grab B, we would grab the key, and then when we print here, the result, we get the value 2. We're essentially telling the computer, hey, I have this variable dictionary. Remember, I can name this whatever I want. I have this variable dictionary. I want you to go find the key B. And this key B, if it exists, grab me the value. So it's going to go into your memory or into the machine's memory. It's going to find where B is stored in our memory and grab the value. So in the bookshelf B, we have the value 2. What if we do C, which doesn't exist? If I click run, I get an error. It tells me,
it doesn't
"Sorry,
find it.
C, but I don't really have that key. And this is what a dictionary is. A dictionary is an unordered key-value pair. What do I mean by that? Unordered means that they are not right next to each other.
Yeah, no.
Remember, with lists,
not
we
really.
access lists with index of 0, then
They
index of
are
1,
next
index of
to each
2.
other.
All those bookshelves were right next to each other. A dictionary, on the other hand, they're all over the place. Although I've put A and B here, this might be in one spot in memory, and this one in another spot in memory. And if I added, let's say, X, this will be in another spot in memory. And this might not be in order. Maybe I've written it A, B, X, but when I actually return the entire dictionary, maybe I don't have this in order. These are all just scattered all across our memory. As you see here, when I receive the dictionary, I get these things in order, but that's only because it's small. If I had a really, really large dictionary, I might not have them in order that I've inserted it in. So a dictionary is an unordered key-value pair. And as long as we know the key, that is, whatever the key that we're looking for, then we just give that. And our computer is going to know, hey, where in memory to look to grab the values. Now, here's a cool thing about data structures, like dictionaries and lists. They're containers around data, right? So this can be anything that we want. Let's say we want this one to be a list, 1, 2, 3. Maybe we want
It's
this to
going
be
down now.
hello.
Thank
and
you.
maybe this is a Boolean value, like true.
Okay.
That is completely valid.
It can be a list, it can be a string, number,
The
float,
second item in the list.
boolean, whatever you want.
And there you go, I get 2.
Dictionary
It's the same with lists.
A.
You'll see this a lot, where if we had a list, or let's call it my list,
2, yeah.
and my list contains a dictionary that has, let's say, A, 1. You know what? Let's just copy and paste this. We'll do this,
Yeah,
So we'll
you
have
can
the first item
insert
in
that.
like this.
It's the entire
Then another
dictionary.
array.
Yeah.
And this time around, this one has 4, 5, 6. So that I can now grab from my list the first item,
0,
and then maybe grab the A.
the A.
So remember, this is a string. And then we want to grab, let's say, the third item. So we'll go
So,
2. If I run this, I should get 3 and 2.
huh.
Now, you might be asking yourself, what's the deal with these data structures? Like, why do we need dictionary? Why do we need lists? Why can't we just have one thing that does everything? So think about that, because in the next video, I'm going to try and answer that question for you.
Yeah, okay, I'm going to stop right here. Okay. Developer Fundamentals 3. I'm going to be taking down this tomorrow. I'm going out for a walk. Sun is down. It's still hot here. But I want to take a walk because it's been Monday, Tuesday, Wednesday without doing any exercise. So I need to go out and I don't know, breathe fresh air. It's very hot in here. I'm going to be switching to probably Instagram and chat a little bit, or maybe I'm just going to listen to some music. But thank you for coming in, and see you later, I guess. Okay. I really need to set up my phone to work with this stream. Oh, wait, what? No, I don't think so.